Hi, so today's Edpuzzle video will be a little bit different. I'm not expecting you to watch the entire thing, only go through as needed, and I'm actually going to only stop you a couple times, and it would be at the end of each page. I'm going to make a note so that you can skip to that, so you can see where the following page begins. And then you can check your work and only use this as needed. You can also see that all of my notes are already filled out. This is for two reasons. One, because I made a video and I lost all of it, which was very sad. But also because I think I can just talk you through it since these are just practice problems. So what I need you to do is just go through and you can shut this video off, and if you haven't already read through what it said on the schedule, you should just be practicing these problems. So go through 67 through 71 are practice problems, but some of them you might need a few hints and a little bit of extra instruction, so you come back here for that. So in this one, on the first page, so this is page 67, it says picture to the right is the graph of this function. So the first thing that I did was label it. Make sure that yours is also labeled. And then over here it said find g prime of -4. If I went over to g prime of -4, I could just try to estimate what that is. But since I have the graph of g of x, what I can do also is I distributed this and I was like, well, g of x. And so I expanded this and then I put it into a polynomial form. Took the derivative, so up here I went from this step to this step, and I said g prime of x is equal to x plus 2, and then I substituted in x equals -4, because the derivative is the slope of the tangent at this particular value of x now. So g prime of -4, I would go to -4 and I'd substitute for x, -4 plus 2, and I get -2. If I draw this line, I can actually see that the slope of this line is -2. So the slope of the tangent at x equals -4 is -2. In the next one, find the equation of the tangent line. To find the equation of the tangent line, you need two things. You need a slope and a point. The point is going to be from the original function. So g of 4 is equal to -2 came from up here. So g of 4 is -2. I substituted in -4 and got out -2. Which is just a coincidence that the slope and the derivative, or I'm sorry, that's the same exact thing, that the slope and the point happen to have the same x and y value. Whatever, it just happened that way. G prime of -4 we already found was -2, so this is always y minus y1. I should put this up here so you can see it a little bit more. Y minus y1 is equal to m times x minus x1, and because these were both negative, it became plus positive. Next problem, anytime you're asked for a tangent line approximation, or it says use the equation of a tangent line and it asks you to find the value of y. You need to find the slope and the point first, which we already did this. We have the equation from up above. It's only after that point do you substitute in -3.9. Don't try to find the slope and the point at -3.9. It's going to be gross. Don't do it. And if you could find the point at -3.9, which you can in this one, it kind of doesn't give you any reason to find the equation of the tangent line other than, or I'm sorry, the tangent line approximation. This one, we're just trying it though to kind of see that yes, it does work because we can actually find the function value at -3.9. So this is just us working with it for the first time, the tangent line approximation. I can see these two values, -2.2 and -2.195. So if I were to compare them, I can see right now which one is bigger and which one is smaller. I can see that this is a larger value because it's slightly less negative than this one. But sometimes you'll be asked, is this an over or under approximation? And then you would have to just know this without actually being able to see the function value. You can use the tangent line to approximate function values very close to the point of tangency. So I'm saying all of these things all at once. I'm going to go back and re-explain better than I am right at this moment. If I want to know whether this is an over or under approximation, and I'm telling you that we can use a tangent line to approximate, the reason why, and both of these questions can kind of be answered at the same time, is you see how here we've got this curve. If I didn't actually know what this curve was to be able to find the value of g of x at x equals -3.9, what I could do is, you see this equation of the tangent line, or this tangent line right here, how it's very, very, very close to this function. I could zoom in further and further and further, and it would look like it was further away, but it's going to actually be touching tangent line dodges at one place at x equals -4. That means at -3.9, right there, I can see that this value, that red point, it's kind of hard to see, is very, very, very close to this value at -4. But this will give me a better approximation. So if I know the equation of a tangent line and I can substitute in x equals -3.9, it's going to be super close to the function value g of x itself. The next thing I want to know is this an over or under approximation? This graph is what we call concave up. It looks like a smile. Anytime you have something that is concave up, it doesn't matter where I drew a line around this. It could be here, it could be here, it could be here. But you see how all of these tangent lines, like this one, is under, except for the point of tangency, but it's under the curve. That means anytime here that I have something that's concave up, I'm going to have an under approximation for a tangent line approximation. In contrast, if I have something that's concave down, it looks like a frown. My face actually isn't very good at doing that. Like, I'm not very good at frowning. So concave down, if I drew a tangent line, any tangent line is going to be above, except at the point of tangency, although that one's above all the time because it's a bad line. This would be an over approximation. Okay, so moving on, next page. On page 68. We've got pictured to the right is the graph of the function g of x. So here it is, g of x. Oops, this is kind of crooked. There we go. I want to label it. And again, I know what the function is, but that's okay. I've just got this graph to the right. And it says, based on the graph, at what values does the graph of g of x have a horizontal tangent? Horizontal tangent is if I was making a tangent line, so just touching the graph at one location, that it would be horizontal, which is happening right here when x equals 1. I knew I drew a lot of mine. At x equals 1, g of x is neither increasing or decreasing, which is how I know that there's a horizontal tangent right at this moment. It's kind of at the top of a hill. It's at a relative max in this case. And then it says show an algebraic analysis that supports your answer. An algebraic analysis, so let's think about this. If I have a horizontal tangent, the slope of the tangent is the same thing as saying I have a zero slope. So a zero slope on g of x. 0 equals the slope of the tangent. And we know slope of the tangent is derivative. So I find the derivative using the power rule. So I took 1/2 times 2. I get 1, subtract 1 from my exponent. The derivative of negative x is -1, because this is the slope, plus 2, the derivative of 2 is 0. I set this equal to 0, add, multiply, I get x to the 1/2 is equal to 1, and this is where I get x is equal to 1. So I just showed it algebraically. G prime of x is less than 0. So this is one that I wouldn't even look at the graph yet until I justify. So I would say g prime of x is less than 0 when g of x is decreasing, and then I would look at the graph. They're like, okay, where is g of x decreasing? So going down, I'm reading from left to right. I'm going to do that here. So I'm going from 1 to infinity, going on forever and ever and ever. I know g of x is decreasing. Same deal here. When g prime of x is greater than 0, I want to write, well, g prime of x, a slope is greater than 0 when g of x is increasing. And then I look on what intervals is g of x increasing. And this is actually only from 0 to 1, just because this function is not defined for any negative values of x, because the square root of x right here. And the next one, for what values is the slope of the tangent? Anytime you see that, slope of the tangent is the same thing as the derivative, equal to 2. So you need to find the derivative. This was using the power rule. And if you're wondering where exactly I got this 2x to the 1/2 from in the first place, it was just because this was x, the square root of x, which can be written as x to the 1/2. So I found the derivative, set it equal to 2. I'm adding on both sides. It's kind of weird, but you get x is equal to 1/9. Go through my work if you didn't get the same thing. Make sure that you're trying this on your own. Find the equation of the tangent line drawn to the graph when g of x is equal to 4. So we need two things to find the equation of the tangent line: a slope and a point. The point will be g of 4, which if you go up here, you can just look at what g of 4 is, which is 2, or you can substitute in here for x. The slope of the tangent is where we found the derivative up here. We substitute in 4. You're using point slope form, so y minus y1 is equal to m times x minus x1. And moving on. Okay, this one, I'm guessing I'm going to get a few new viewers for this part just because it looks funny and you're going to be like, we didn't do this before. And then you're going to fight or want to fight. And then I'm going to say, no, don't fight. I'm peaceful. And you actually have done it before. It just looks a little bit different. So in this one, we normally have to, in the super long problems where you had to make a really, like it was one problem and then you had the rest of the page and you had to make a chart, and then after the chart you had to figure out where is the function increasing, where was it decreasing based on where the derivative is positive and negative. Same idea here, except they give you the chart. Here's x, and it says in the table the zeros indicated are the only zeros for h prime of x. So normally we have to find h prime, we have to set it equal to 0, we have to make the intervals. Here we find where h prime of x, we set it equal to 0, so I can see at -2, that's my first location, at 7 is my second one. If you need to make another table on the side, do it, but I just put my intervals up here, and I said from -infinity the whole way to -2, because this is a polynomial function, which means it's nice and smooth and kind of does like nice predictable things. -infinity to -2. Then I start again at -2, because remember even though it says 0 right in here, we're starting at -2 because that's the place where the derivative was 0. So there's an infinite number of numbers between -2 and 0. I need to start right at -2. So this is the interval -2 to 7, and then 7 to infinity. The next thing that we do is figure out whether my derivative is positive or negative. The nice thing about this is we already know. We could pick our favorite number, -8, -5, and I can see I get positive answers, which that allows me to know that h of x is increasing on this interval from -infinity to -2. Same deal here. You can pick 0, 3, or -5, or I'm sorry, +5, and I can see I get negative, which means if h prime is negative, h of x is decreasing. And then from 7 to infinity, again, there are two options, 10 or 12, but these are all going to be the same numbers. It's not like one is going to be a positive h prime and a different one would be a negative. That's not going to happen, as these were the only zeros at -2 and 7. Okay, so then we do some work here, and it says increasing or decreasing. Remember, h of x is increasing where h prime is positive. So that's my justification. H of x is decreasing where h prime is negative. That's my justification. And then write the intervals down where those things are happening. At what values does h of x have a relative maximum? Maximums occur when you go from, this would be for me, but I think you're looking at me backwards, but either way, increasing to decreasing, or you can say the slope is positive and then negative. Over here, positive to negative slope is a relative max, and this just says at what x values. So I can say at x equals -2, h of x has a relative max as h prime changes from positive to negative. Be really careful about wording. Don't say decreasing when you mean negative. Don't say it or the function when you mean h of x or h prime. Be very specific with your wording. Then the next one says relative minimum. This one's also important. That if I look here, there's no place where my slope goes from negative to positive. So I'm just saying h of x does not have a relative minimum, but I'm still justifying my answer, as h prime never changes from negative to positive. You might notice on here that I just have ht for horizontal tangent. That's because if the graph of h of x is decreasing, then decreasing some more, there's going to be a place where it kind of levels off for a second, which is why the derivative is 0. That's why h prime is equal to 0. But it's not producing a relative min or max, so just a horizontal tangent. At x equals -2, h of x has a relative maximum, but I can also say that there's a horizontal tangent as the slope of the tangent, h prime of x, is equal to 0 at -2. Think about horizontal tangents are like the most basic. So if I say something is a rectangle, it's not necessarily a square. if I have a horizontal tangent, it's not necessarily a min or a max. Like the min or max would be like the square kind of situation. A square is a rectangle isn't necessarily a square. A horizontal tangent isn't necessarily a relative max or min, but a relative max or min is going to be, well, that's even a hard one though, because there are some cases where you've got a pointy top, so maybe let's just get that square thing and take that analogy and throw it out the window. Probably a square window, but maybe a rectangle. Who knows? Okay, so relative max, horizontal tangent. This one's also a horizontal tangent. Okay, another problem. This says h of 3 is equal to positive 2. What is the equation of the tangent line? The equation of the tangent line, you need two things, a slope and a point. H of 3 is 2, so this is where the y minus y1 is equal to m, I'll get that in a second, x minus x1, because it came from that point. And you're like, where did this negative 3 come from? We know how we have a chart. H prime of 3 was negative 3. It was given to me in my chart. If I want the equation of the normal line, or it might say the equation of a line perpendicular to the tangent, it's going to be the same function, or the same equation, except this negative 3 will be the opposite reciprocal slope. So this is negative 3. My opposite reciprocal is 1/3. Because remember, if you have a line like this, one should be positive, one should be negative, in order for them to be perpendicular, and they have to be opposite reciprocals. If you want the tangent line approximation, you must find the tangent line first. So I'm using the equation of the tangent line. Then I substitute in 3.1 in for x. And then you can solve this and get 1.7. Ooh, going back to limits. What? Okay, the limit is x approaches negative infinity of h of x. This one takes a little bit of work because this was graph of h prime. And that means h of x is increasing, relative max, decreasing. So if I draw something that kind of looks like that, and I don't care where this happens exactly, this is going to be way off, but increasing, relative max, decreasing some more. If I say the limit as x approaches negative infinity, going left, oh, I can see my function value is going to negative infinity. If I say the limit as x approaches infinity, going right, I can see my function value is going to negative infinity still. Page 70, let's do this thing. Woo! Do you celebrate when you turn pages? Maybe you should. Maybe if you haven't, maybe that's a good idea. Okay, so on this one, we've got on what intervals is f of x increasing, decreasing, justify your answers. This f prime is already given to me. So normally on those long problems that we had to do before, we had to find the derivative, set it equal to 0. This derivative is already given to me, and it's really nice because it's already written in factored form. So if I set this equal to 0, so 0 is equal to all of these. Remember, for factors, you can set each one of them equal to 0. And so then I've got my intervals from negative infinity to negative 3, because I'm stopping at negative 3, I'm stopping again at 0, and then I'm stopping again at 2. So I'm writing all my intervals here. The next thing that you need to do is substitute in a number from negative infinity to negative 3, then the interval from negative 3 to 0, 0 to 2. And whenever you're substituting this, be sure to substitute it into the derivative. So the derivative here, I can see, is going to be positive if you sub in some number between negative infinity and negative 3, like negative 10 or negative 307, doesn't matter what it is. You're going back up here. And what I would do in this one, and you can kind of see how I wrote multiple things and it looks like I erased, and I have positive. It's because if I put in a number like between 0 and 2, I put in 1. When I went up here, I'd say, oh, well, 1 is going to be positive, times 2 minus 1, which is positive, times 1 plus 3, which is positive. I'm not even thinking of what the numbers are in my head. I just know it's positive times positive times positive, which is still positive. This one asks about when is f of x increasing. Make sure that you're writing f of x is increasing, like you actually label it. F of x is increasing on the intervals, and write down your intervals. And the reason is that f prime is greater than 0. F of x is decreasing. Again, put the intervals that were up here as f prime is less than 0. Relative mins and maxes. So this one's talking about relative minimums. F of x has a relative min, and I always write this part in here, whether it's a min or max. So decreasing and increasing, and you can see I draw it in there, and then I wrote min. f of x has a relative min when f prime changes from negative to positive, so I justified it, which occurs at x equals 0. If you wrote C part or C number 16 and because you wrote increasing and decreasing up here, you could say f of x changes from decreasing to increasing at x equals 0, but only because you did the work here, and you need to show me in some way that you have to like go to that. Because f prime was given, I'm totally fine to use f prime changes from negative to positive. In 18, a relative max when f prime changes from positive to negative. So I'm going with what's given as far as the f of prime, because that's what was given to me first, so that's the one I'm going to use in my justification. This occurs at x equals -3 and x equals 2. The next one asks to find the equation of a tangent line. To find the equation of a tangent line, you need two things: a slope and a point. I'm given the point. That's where the y plus 1 came from, because here's the y1. The x1 is 4. That's where this is coming from. To find the slope of the tangent is the derivative. So this f prime at the top, you're substituting in f prime of 4, all those values in that top function, f prime, and then I get -56. That's where this is. If it says approximate the value of 4.1, this is a tangent line approximation. I just did the tangent line. That means my x value, this x value, I'm going to substitute in 4.1. And you might be asked later, is this an over or under approximation? Actually, you wouldn't be asked that yet. There later units, they are going to be asked about that once you can figure out concavity, but not yet. At least not on this type of problem, unless it says concave up or concave down. If it said concave up, we would know it's an under approximation. Concave down, any tangent line is going to be an over approximation. If it asks, why is this a good approximation? It's just the tangent line touches f of x at x equals 4. This point is super close to f of x as its tangent line at 4.1. Nothing fancy, but that question does come up sometimes. Last page. Okay, on this one, this graph is of p prime of x. Label this. I know it's labeled down here, but I would even label it bigger up here. It asks p of x is decreasing. Before you even look at this, I would use the justification and say p of x is decreasing when p prime of x, okay, when the slope is negative, so p prime is less than 0. Once you write out that justification, then go over your graph and think about what does it mean for p prime to be negative. Because this is a graph of p prime, I'm looking at all negative values or all those below the x-axis. So I can highlight anything down here. Decreasing, I would only want to go the places where it's below the x-axis. So from the interval from -3 to 0, and then 0 to 3, as those places it touches the graph of p prime of x at x equals, or I'm sorry, at p prime equals 0. And I want it to be less than 0. There is something on this, like there are some books that argue this, and there are sometimes on the AP exam or other places, if it's your only choice to say that the p of x is decreasing from -3 to 3, choose that one, because there are lots and lots of arguments between AP teachers and textbooks, but I would rather you know this version, and then -3 to 3, if that was an answer choice, to choose that one. P of x is increasing where p prime is greater than 0, so same idea. So do this justification first, then go over to the graph. It's anything above the x-axis. So remember, you're going your x value, so -infinity, my x value, to right here, my -3, and then 3 to +infinity, because these are my x values. Relative maximum, again, I would justify. So p of x reaches a relative maximum when p prime changes from positive to negative. If you're looking at the graph, this would be you're reading from left to right. So here's positive, and I'm going over to the right. Hey, I got to negative. So there is a relative max here. If I go to this place over here, at x equals 3, this is negative to positive if I'm reading from left to right. So this is where a relative minimum occurs. Here, because I'm going from p prime is negative to negative, and it crosses over 0 here, negative to negative is just a horizontal tangent. Technically, at x equals -3, x equals 0, and x equals 3, there are horizontal tangents for the graph of p of x, or p prime of x is equal to 0. But more specifically, I can say that there's a relative min and a relative max. Last one, if I want to approximate the value of p of 1.8 using a tangent line approximation, I must use this point and a slope first at x equals 2, because this was the point that was given to me. So if I go over here and I'm like, okay, this is my point, and then I want to figure out what my slope is, I would want p prime of 2. Just like in all the other problems, we had the same x value. P prime of 2, this is a graph of p prime. P prime of 2 is at -4. It's just a point on the graph, which is where this is coming from. Y minus y1 is equal to m times x minus x1. Then you can substitute in 1.8 and solve that. Okay, thanks so much for being great. Let me know if you have any questions at all. Bye!